when you raise a power to a power, the quickest way to get a number powerful is to multiply. So we're going to multiply the powers together. This is like q times itself 3 times, doing that 4 times. So 3 times 4 is going to make this q to the 12th power. And r has an understood 1 there, and 1 times 4 means that's going to be r to the 4th power. Now you know you've got it completely simplified when all of your exponents are positive and you don't have any of the same variable repeating. And since our exponents are positive and I don't have another q or another r to combine with them, that is completely simplified. Look at number 38 over here. Number 38, here's a parentheses here because it's all being multiplied. Here's another parentheses. This second parentheses has a power on the outside of it. I need to apply that power to everything in those parentheses before I move on. Now there's other ways and steps to go about this, but what we've been talking about in class, and I said if we use the same steps over and over, I'm gonna do power to power first. So I'm gonna rewrite the first one just as it is, and I'm gonna write without the parentheses, multiplication wise. So 12 times x squared times y to the negative second times, and I have 4 to the negative 7th power. That power is gonna go to everything in this parentheses. X is gonna be to the negative 7th power. And y has a power already of negative 3, so I'm going to multiply power to power. Negative 3 times negative 7 makes y to the positive 21st power. Okay, the second thing I've asked you guys to do is to clear your negative exponents. Now some of you guys have been adding and subtracting like bases with the negative numbers, and that's absolutely fine. But again, just to keep things the same over and over and consistent, I'm going to get rid of the negative exponents first. So this is the same thing as that being over 1. So if I leave everything in the denominator, in the numerator, anything with a negative exponent is going to go to the other side of the fraction bar, and then the exponent will become positive. So y is my first thing I notice has a negative 2 exponent. Take it out of the numerator. I'm going to put it down here in the denominator and make it a positive 2 power. Same thing with my 4 to the negative 7th power, and I'm going to write it first over here, 4 to the 7th power, just because I want to put my coefficient first. X has a negative 7th power, so I'm going to bring it to the bottom, it becomes positive. And everything else on the top has positive exponents, so it's going to stay right in the numerator where it's at. Okay, so now I'm going to simplify. Now, I'm going to be honest, I do not have a calculator with me, and I do not know what 4 to the 7th power is off the top of my head. So I'm going to leave that as 12 over 4 to the 7th power right now. The answer key I post will have the final answer. If that, when you do 4 to the 7th power, if it can reduce with 12, go ahead and reduce that fraction, but it does not apply to the other exponents. I just don't have the calculator with me right now. Looking at my x next. I have x in the numerator and the denominator. There's only 2 x's on top and there's 7 on the bottom. So there's more on the bottom, which tells me x is going to end up in my denominator. And when I'm dividing like bases, I'm going to subtract these exponents. So I'm going to do 7 minus 2 to give me a positive 5. Okay. If I just kept x at the top and did 2 minus 7, I'd have a negative 5 up here. And then I'd have to go ahead and move x to the bottom of the denominator again to make it positive. So I'm kind of saving myself that step by seeing which side of the fraction bar has more of them on it to begin with. I'm going to mark off what I've used here. I've used the 12 in the x and I've used the x's. So the only thing I still have is 21 y's in the numerator and only 2 in the denominator. So y is going to remain in my numerator. And again, I'm dividing the same basis. So 21 minus 2 is 19 for the power. Okay, both of my exponents are positive. There's not any more y's to combine with that y or any more x's to combine with that x. And again, you might be able to reduce that fraction. I'm just not sure right now without a calculator. So we'll check on that one later. So for right now, I'm going to circle that and say we are simplified. Number 41. We have a and b. They have fractional exponents, and they're raised to a power out here. Power to a power, we're going to multiply. There's not 2 a's that we're combining or 2 b's we're combining, just 2 powers. So power to power, we're going to multiply. Remember, when you multiply fractions, you don't need a common denominator. Look at this like 4 over 1. So when I have a, if I do 3/4 times 4, 3 times 4 is 12, and 4 times 1 is 4. So I have 12 over 4 for a, and then b, 7 times 4 is 28, and 8 times 1 is 8. Okay, so I can now look at this, and I could be done, but I could reduce these fractions a little bit. 12 divided by 4 is 3, so let's go ahead and just make that a to the 3rd power. And 8 does not go evenly to 28, but if you notice 8 and 28 are both even numbers, and I notice that they both can be divided by 2. But just to make it a little quicker, I also noticed that 4 can go into 8 2 times, and 4 can go into 28 7 times. So I'm going to divide them both by 4 to reduce that fraction. So 28 divided by 4 is 7, and 8 divided by 4 is 2. and I'm going to leave that as my final answer. My exponents are both positive, and there's no other a's or b's to combine with them. I want my fractional exponents to remain in an improper fraction, not a mixed number, because if I was going to transfer it to radical form, I would need a power and a root, and a mixed number would mix that up. So I'm going to leave it in an improper fraction form. Number 43, 21 and 3. They're not in parentheses with any other exponents. They have no exponents with them. They're just coefficients. So I'm going to treat it like I would any other two numbers. 21 divided by 3 is 7. So I am simply going to do 21 divided by 3 and leave it 7. Okay, the bigger number's in the numerator, so it's not a fraction, it's just 7. I have a negative exponent here. I would like to make that exponent positive before I move on. So I'm going to take that x to negative 1 and take it from the denominator and move it into the numerator, and I have a positive 1 exponent. And now my x's are both in the numerator. That means they're being multiplied times each other. Same side of the fraction bar, multiplying the same base, we're going to combine those exponents and add them. So 3 plus 1 is x to the 4th. And there's nothing left in the denominator, so I don't even need that fraction bar. I'm just going to erase it there. And my answer is going to be 7x to the 4th power when that's simplified. Now, if you didn't move that negative 1 down there, you would have had 3 minus negative 1. And a lot of people make mistakes when they're subtracting negatives or forgetting that they have two negatives there. So clearing the negative exponent first kind of makes it easier to not have so many mistakes. All right, we're getting there. Number 45. Again, we've got this big old parentheses. Everything in here is brought to the negative 4 power. So I want to first go ahead and take everything and raise it to the negative 4 power before I move on. So I'm going to have 3 to the negative 4 power. C is to the 3rd power to the negative 4th power. So again, I'm going to multiply power to power. That's going to be C to the negative 12th power. And don't forget about the denominator. It's also brought to the negative 4 power because it's in those parentheses. Power to power, I'm going to multiply 5 times negative 4. I'm going to have E to the negative 20th power. Okay, and again, I want to clear my negative exponents first. So anything that's on the numerator with a negative exponent is going to move to the denominator and become positive. Anything in the denominator that has a negative exponent is going to move to the numerator. In this case, every single thing has a negative exponent. So 3 to the negative 4th power is going to go down here to the denominator and become positive 4. C to the negative 12 is going to go to the denominator and become a positive 12. And E to the negative 20th is going to go to the numerator and become positive. Okay. Now I don't have any variables that are similar. I don't have the same base of anything that I can combine. So all I did here was get everything positive, and I'm done. Now I can do 3 to the 4th power. And again, not my calculator, but I know 3 times 3 is 9. Times 3 again is 27. And times 3 again is 81. So that's going to simplify to 81. So in my numerator, I have E to the 20th power. And in my denominator, I have 81 and C to the 12th power. And I'm going to just check. There's no negative exponents, and I don't have any two of the same variables that I can combine. And I don't have a fraction I can reduce anymore. So that's as simplified as we can get there. Okay, number 50. Make sure we can see this on here. Again, parentheses and power to a power. I want to make sure I take care of those power to powers first. So in this case, I'm going to have, I'll write it down here so we can see it better. 5 is going to have the negative 3rd power with it. A, power to power, 8 times negative 3 is negative 24. Okay, and in the denominator, I've got 10 to the negative 3rd power. And then A to the 6th power to the negative 3rd. So power to power, I'm going to multiply. So that's going to be A to the negative 18th power. Okay, and I'm going to move all my negative exponents, those bases with negative exponents, to the opposite side of the fraction bar. So again, everything in here happens to have a negative exponent, so everything's going to move. That's not always the case. 5 to the negative 3 is going to go, I'm assuming this fraction bar down here is 5 to the positive 3 power. A to the negative 24 is going to go to the denominator. A to the positive 24 power. 10 to the negative 3 was in the denominator, so it's going to go to the numerator and become positive 3 power. And A to the negative 18 is going to go to the top and become a positive 18 power. Did that a little far, I'm going to erase that. And now it's up to me to simplify my numbers. Now 10 to the 3rd power. 10 times 10 is 100 times 10 again is going to be 1,000. Okay, got that. In my numerator, I have 5 to the 3rd power. 5 times 5 is 25. Times 5 is 125. And then I've got my A's. I've got two variables that are the same. And again, 18 in the top and 24 in the bottom. So you can picture writing 18 A's across the top and 24 across the bottom. And crossing off the pairs, since anything divided by themselves is 1, I would cancel everything off the top and I'd still have some left on the bottom. And when I'm dividing the same base, I'm going to subtract these exponents. But I'm going to go ahead and leave a at the bottom and subtract from the bottom because there's more down there. So 24 minus 18 leaves me with a to the 6th power. Okay, now I'm looking to see if I'm done, and I'm just about done, but I noticed 1,000 and 125, they've got some things in common. And so I can go ahead and see how many times 125 will go into 1,000. So I've got 125 twice is 150. I'm sorry, 250. And 250 twice is 500. Okay, that's 4 times total, and 500 twice is 1,000. So that means 1,000 divided by 125 is going to be 8. The bigger number's on top, so it's going to be a whole number 8, not a fraction. So 8's going to be in the numerator, and I still got a to the 6th in the denominator. And no negative exponents, no variables repeating. I have all my fractions reduced, so that's finished simplifying. Last two, we're going to go back to these radical and rational exponent forms again. Take 4x to the 1/2 power and put it in radical form. The whole thing goes into the radical because it's in parentheses. So 4x goes into the radical. They both have a power of 1. You do not need to write it. They both have a root of 2. You may write a 2. You don't need a 2 in a square root symbol. 4 has a perfect square root. 2 times 2 is 4, so the square root of 4 is 2, so it can come out of the radical sign. X has to stay underneath the radical sign because there's not a square root of x. That's my simplified answer. Number 8 is in radical form. I'm going to rewrite it in rational exponent form. I only